Hello everyone. As I mentioned in the class that I will provide you implementation of link-based data structures. So far we have studied list, queue and stack data structure. You already have implemented these data structure in the class, and in the book implementation is explained, well explained. And as I mentioned also that with some C++ concepts, I will little bit expand the implementation. In the book, the implementation is very compact, and sometime some students having some difficulties in understanding the implementation. So through this implementation, I will try to make the things simple. I will just expand them. So let's review. We have a list data structure implemented in the class. As you know, list is a data structure that we can add, delete in Node at any place. We can add, delete at the front end or back end or between uh, these two ends anywhere. And you can see the node class. uh, Node class has two data members and many function members, and you can also see the uh, data members and data member only one member and the um, function members. I hope you understand well because we have spent a lot of time on it in the class. And similarly, we have a queue data structure that has two ends, front and rear ends. We can delete the elements from the front end and we can only add the elements on the rear end. We cannot delete or remove elements any other place from any other place. And you can see this implementation, and you can see here node class is a little bit different and maybe more basic, and the linked queue is here, two data members and other operations in the queue. And this is the stack. Stack data structure has just one end, top. So we can just delete or add elements from this top end, and the other end is dead end. And we cannot remove or add elements between these two ends. So you can see the um, class diagram for the linked based stack database data um, structure implementation. So I will implement these data structures, and I will use the C++ concept. I hope you understand them. Basic input output. Instead of printf function, I will show you using of cout and cin object from the input output stream, and um, getter and setters already you know and also you are using, and then I will also use the const um, keyword at different places in the function's header, and also I will use the concept of friend function, overloading, operator overloading, very important concept, and I will use it, and we will see the benefit of using this overloading operator. You know the method overloading. This is the concept very similar, but here we overload the operator instead of a function. And then the you already know the concepts of constructor, default constructor, constructors, member initializer, list, and copy constructor, very important actually. And then the destructor, and another concept that separating header and the implementation. That means we can separate the implementation or function bodies. We can have a separate place for the function bodies, and just the prototype of the functions we can separate it. It also has some benefit, and it is a good software engineering practice. And you know about the pragma once. This is something preprocessor directive. Most of the time we were using in the class. So we can also use for the similar purpose. If not defined, then define and end if. Uh, I am using all these concepts because we will also have class templates and function templates. So for the class templates and function templates, so these concepts are very important. So in my first phase, I will implement without templates, and then we will um, make the templates of the same classes. So let's start from the node class. So first you can see here uh, two data members, same, that mean data of type integer and a link of type node, and then constructor, and then get data, set data, getter and setter for the data, data member data, and get link, set link. So two function, getter and setter. And this is important. We used to do this display function to see the data in the node. So we will have another way, and I will explain in the implementation that we can use overloading, operator overloading, uh, to get the information from any user defined class such as node. So let's do the implementation. So start the Visual Studio. New project. We may have here a new folder for week 12, and I can select this folder, data structure week 12, and the project name is data structure. So this is the name of the project. We are going to create an empty project. So add one header file, node head. So let me uh, if not defined, and node underscore h. So node is the name of the header file and underscore. This is just a naming procedure that we usually do, and then define. If not define, then define. It prevents for multiple copies um, of the same class or header files. So, and if. So we can have here, okay, let me little bit increase the size of the font, maybe now visible. So class node, and this class has two parts, private and public. In private part I have data, that mean data member, data in the node, and then I have another one, node pointer link, another data type, a data member. So this is something pointer to the link node. So two data members, and then we will have one function is constructor, and this is something initialization of data members. Already you know, null pointer and body is empty. So it is something end of default constructor, default constructor. And you may write some other constructors, like you can have a data, and then you have input argument, and you can put here data, a data, and the second one is link is something null pointer. Null point. So this is something end of constructor, and then okay, here int is fundamental type, as you know. However, for the user defined types, we prefer const and the reference, right? So that mean input argument a data of type integer, and we do not want to change it inside the function. So it is if we are using just fundamental types, then normally we do not use const, But if we are using um, the objects, that means user defined type, then it is recommended, because if we just pass by value, then if the object is too large, then we are actually making copies of the object. That is something a burden. So now we have two constructors. One is the default constructor, just without any argument, and the other one having just one input argument. Then we need some getters and setters. So let's see, void set data, and we provide data. So the same I can put here, and here is the body. Data is set to a data, assign the value, right? So this is something end of set data function. So similarly, we have a setter, set link, and here we provide a node pointer next, and we simply set the link to this node. So it is something end of set link. So then we have to make two getters. Int get data. So uh, um, very simple function, just return the data. So end of get data. So here, if I put here const keyword, it means that this function will not change any data member. So because we are interested in just getting the values, not changing the values. So getters should not change any data member. So it is a good practice to put const at the um, end of argument list. So this is something, the argument list is something like this, and then we, after the closing brace, we can put const keyword. So it is good practice. So node pointer, we will get link, no input argument. We can put here const also, and then the body will contain just very simple one statement, return link. So end of get link function. So just comment this. So we have now getters and setters and two constructors. Let's make one CPP file, new item, and its name is data structures and test. Add here. So so here uh, let me include some libraries. Header files include um, input output stream. This is the one of the header file for input output streams in C++. And also I will include node class. And then please also see this one, using namespace std, standard namespace. It is also very important concept. Please read about it and you can discuss with me in the class. Many standard functions, they are related to this namespace. So then we have a main function. As you know, we must have to test or run our program. This is something one basic thing. And now uh, uh, if I want to use any object of type node, I will just write like this one, node n1, and I can put some value, and this way I can create some node. Now I want to print it. So please see the example first. Let's see, we have an integer a and its value is 10, and we have a double b, its value is like this one, and we want to print it. So to print it, we will use cout object with this operator double angle, and I will just have a here, and then if I use again this operator, and I am using end line, next line, and then I can use here for b. So this is something, cout is one object in input output stream, that means of type input output stream, and this is the operator. This is operator. So in this way, this is something similar as we use printf function. So let's see. Let's see, there are some errors. Oh, where we have some problem. So let's run this one. So we have some error. Let's see, missing column before. Okay, let's see, there may be I forget this one. This is something the so so we can use C out and the object and a double angle um, uh, operator to print the uh, different types. This is something integer and this is a double, right? So I want very similar way. I want like this one. If I copy here, I want here like this one. So here is a problem. I want to overload this operator for the type note, so that to print some data from the user defined um, type, I can use the same facilities provided by the C++. So because we have not defined yet the overloading of this operator, so we are facing some error, right? So define let's define, right? So go to the node class, and here we will have overloading. I will have I will implement a friend function, standard namespace, having a output stream. This is one um, type of object. So I want output, and the function name is operator, and then this is the operator I want to override overload. And again, this is very important here. So if we arguments put here, out stream, output stream, and its a reference, and you can give any name, output out, and node, here is something n. So this is the declaration. So let me briefly describe this overloading. Operator overloading means that the operation performed by the operator depends on the type of operands provided to the operator. That means if the integer is provided or double is provided, then this double angle printer operator already already defined. But if we have our own type, then we need to overload it. So C++ lets you extend operator overloading to user defined types, that mean classes. So this overloading is similar to function overloading, where you have many versions of the same function differentiated by their parameter list. So here we may have many versions of the same operator differentiated with the type. So this is the syntax. How can we do? Um, sorry. Uh, this is something. To overload an operator, you use a special function form called an operator function in the form of operator, and then this is the some function the operator. So return type, operator, parameter list. So we can overload, plus, minus, and many others operator, double angle, double less than sign, and greater than sign for input stream. So we can define it. So please study about it. I hope you have studied it in your C++ class. So let's see out, and we define. So n is the object of class node, and then I just want to print data. That's simple, right? And then I am returning this object out. So normally this operator overloading function, we make it a friend function, and also it is inline function. So I hope you know about the friend functions. Friend functions have some privileges. They can access private data. So let me now let us see here. We are doing here in the test class that we are creating a node with some value 20 integer value, and then we are using the built-in C++ facilities, and we are overloading the print function print operator, this one just like printf function, cout object, and then the operator, just like dot operator or other operators we can use with objects. So let's see, run this one. So you can see we can print it. So this is one reason that I want to show this implementation. So we do not need now any display function. Normally we have a void display function in many data structures. So we do not need this kind of function. Usually we used to do, so no need, so we can delete it. So 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 we can delete this one, and let me copy this implementation. We'll see. So I will provide as a so node class. Sorry. So so this is something, the implementation of node class. Another concept we can use here, that is something named as separating the definition of the um, definition of the functions. So if I just copy these functions, and this is the end of the list class, node class, and here I put, and what I'm going to do here, this is something the header, and here this is the, and put semicolon, and just the header. So so just a constructor, and the default constructor, it is something, and is something related to the body. So and here end of data, and here I am removing the um, body, and just this is body, and this is the body. So this is something you can see the prototypes. So it is a good idea actually to do to have separate implementation. Now uh, this is something a node class. If I put here, and I am putting 2 colon, so this 2 colon is something resolution operator. It means that the node function belongs to node class. So I will copy this node and 2 colon resolution operators, and I am putting here. So then, because these two functions are constructor, and you know the constructors never return anything, even we do not we do not use void here. So I will put, so it means set data function is a member of node class. That means it belongs to node class. So similarly, so just before the name of the function, we need to add class name colon colon, that is resolution operator, and here resolution operator, and here resolution operator. So what we have done here, so basically we have done the um, implementation. We have separated the definition implementation of functions from their headers. So this is just a interface, right? Prototype. So we can make a separate CPP file, and we can then include here. So this is something one way that we can separate. So let's now test. Same thing. So this way we can okay, let me copy for your reference. I will upload this ppt file for so this is something you may not confuse. So duplicate, so this is something just headers, and we may have one more implementation. implementation is this one. Function bodies. Function bodies are implementations. So we have separated actually. We have separated two things, headers and bodies. So this is also very common practice and it has some advantages. So uh, please see this carefully. So now we have completed the implementation of the node class, and now we will move for the for another header file, that is something linked list.